Hello, what we're going to be looking at in this video is how to make a class that can be accessed by multiple threads safely. So the class that we will be looking at is an implementation of a stack as a linked list. So if we go into JGrasp, basically what we have here is we have the class called linked list stack. Uh, we have one instance variable, a node called first. If you scroll on to the bottom of the class, we're also including the class called node, where we have an object that stores the data of the object called data, and then we have another node object which points to the next node in our linked list. So after that, we have three methods. The first one, our push method, adds an element to the top of the stack. The second, the pop method, removes the element from the top of the stack. And then finally, we have an empty method that checks whether the stack is empty or not. So what we're going to do next is, before we get into how we've updated our linked list stack class, we are going to go ahead and take a look at our thread demo, our linked list stack thread demo. So basically what this is a class that implements the runnable interface. So we have the implementation runnable, and that interface has one single method called run. So basically we have a couple of private static variables. The first one is our linked list stack, and the second one is our randomizer. So we're going to be using random numbers in this example. So in our implementation of our run method, basically what we're going to do is we're going to set choice equal to 0. And then if our list is not empty, then we're going to randomize our choice 0 or 1. And then what we're going to do is we're going to check if the choice is 0, we're going to call the push to add a string to the list, and that string will just be a random number between 0 and 999. And then we'll call our push method, passing in our string value. And then we're going to print out that we've added that item to the list, or to our stack. If our choice is 1, then we're going to call the pop to remove a string from the list. So again, what we're going to do is we're just going to go ahead and specify, call our pop method, and what we're going to do then is after we pop the method, we'll go ahead and display which item was popped from the list. And then we're going to check if our list is not empty, then we're going to call our run method again. So that is our implementation of the runnable interface. So now in our main, what we've done here is we've created a new random object called randomizer, and then we've created an instance of our linked list stack. And then what we're going to do here is we're going to create 4 separate threads. So we're going to create thread 1 from the runnable object. So what we need to do is we need to new up a new linked list stack thread demo runnable, and then we'll set that to thread 1. And then what we're going to do is we're going to call the .start method, and this causes thread 1 to begin execution. So the JVM will call the run method of this class. And then we're just going to do the same thing for the rest of our threads. We'll just create a new thread, call the start method, and then we're going to print out that that thread has started. So that is the class that we're going to be using to test our linked list stack. So now let's go into the implementation of a ThreadSafe linked list stack. So the first thing we're going to do is we're going to go ahead and import our interrupted exception. And then what we're going to do is we've added an instance variable that when set to true will lock that instance of the linked list stack. And then when we go ahead and call our constructor, it'll create an empty stack. And what we're going to do is we're going to set lock equals to false, so it is not locked initially. And then what we're going to do then is for each one of our methods, we're going to add the following statement. And basically what that is going to do is that's going to check to see if our linked list stack is currently locked. If it is, then it'll go ahead and sleep for 1/10 of a second. And then after that, it will go ahead and set the lock to true, so the push operation will occur for the specific thread. So what we're doing is now we're locking up our linked list stack. Then what we're going to do is the next few lines is just the implementation from our linked list stack. So we're going to go ahead and run all of those statements. And then after we've run all of those statements, we're going to go ahead and release the lock by setting lock equals to false. So basically what this will do is the first thing it'll do, it'll check to see if our linked list stack is currently locked up. While it is, what it'll do is it'll sleep for 1/10 of a second. If the list is not locked, then it'll just come down, lock the list, and perform our push operation. So we're going to do the same thing for the pop. If our linked list stack is currently locked up, if that's equal to true, we'll go ahead and sleep for 1/10 of a second. And then what we're going to do after that is we're going to set our lock to true, so the pop operation will occur for the specific thread. So we're going to set lock equals to 0. We'll lock the thread so we can go ahead and pop off that first item. So again, the code that implements that is within our lock equal to true and lock equal to false. And the one thing you need to make sure is that you have your return statement where you're going to, so it'll return the element after you've gone ahead and released the lock. And then finally, in our empty method, again, we're just going to check to see if the linked list stack is locked. If it is, then we'll sleep for 1/10 of a second. And then what we're going to do is we're going to return first basically the condition. We're going to check to see if first is equal to null or not equal to null. So basically that's what we're doing. So if our linked list is locked, then what we're going to do is we're going to delay the operation for 1/10 of a second, and then we'll perform it. If the list is not locked, then we'll go ahead and perform the operation. And once we set lock equals to true, that instance of that linked list stack will be locked until the lock value is set to false again. So we will go ahead and click on plus to compile our file, and then we will go into our linked list stack thread demo, click on plus to pause the file, and then we'll go ahead and run our operation. So what we have here is we have the 3 threads have started, and then they've added, removed, added 209, removed 253, added 253, added 195. So each time you run this application, since it's all based on random numbers, you may get a longer string of output. Let me just go ahead and run it again one more time so the output is a little bit longer. So basically it just depends upon how long, what random numbers get generated as far as if we go ahead and look as far as our choice. So the other thing I kind of wanted to show you, if we go back into our linked list stack, and if we initially set our lock value to true, and then I'll go ahead and compile, I'll go back into my linked list stack thread, I'll go ahead and compile that, and I'll rerun. And basically what happens now, since I set that lock value to true, is we cannot move on from here. All of our threads not any of our threads can actually go ahead and do any operations because our linked list is currently locked. So this just demonstrates that when you set that variable that lock variable equals to true, it'll go ahead and lock the list up. So only the method that locked the list can go ahead and perform the operation on it. So I will just go ahead, click on end, go back into my linked list stack and set it back equal to false. So basically that's all I wanted to cover in this video. So this kind of shows you how you can go ahead and make classes that you have implemented thread safe. So multiple threads can go ahead and access that object and becoming corrupted at all. Okay, so again, that's all I had for this video. So we will talk to you next time. Bye.